Before we look at what speaker impedance means when connecting speakers, we need to note that a stereo hi-fi amplifier has two individual amplifiers built in, one for the left channel and one for the right channel. The same principles apply to both amps, so to simplify our discussions, we will talk about only one amp. Most stereo amps are designed for speakers with an impedance between 4 and 16 ohms. The symbol for ohms is the omega symbol. So, you connect a speaker to this amp. On the back of this speaker or speaker box, it says the impedance is 8 ohms. One 8 ohm speaker gives a total load impedance of 8 ohms. This is what the amp is built for, so it's happy. If the speaker was rated at 6 ohms, that's also fine. As is a single speaker rated at 4 ohms. Now the fun starts. What if you were to connect two speakers to the one amp? If both speakers are 8 ohms and you have wired them in parallel, you need to calculate the total load impedance. An easy way is to use my speakers in parallel calculator. This tells us the total load impedance is 4 ohms. The amp is built for this, so that's fine. Now what happens if both speakers are 4 ohms? The calculator tells us the total load impedance is now only 2 ohms, way below the minimum for the amp. One way to solve this situation is to wire the speakers in series. We don't need a calculator for this, as you only need to add the two speaker impedances together. So, 4 plus 4 gives a total load impedance of 8 ohms. The amp is built for this, so that's now fine. Okay, so what if you want 4 speakers connected to the one amp? Let's say you have 4 8 ohm speakers wired in parallel. The calculator tells us the total load impedance is only 2 ohms. That's not good for the amp. If you were to have 4 ohm speakers wired in parallel, then the total load impedance is even less and is even more disastrous for the poor amp. A solution is to use a combination of series and parallel connections, which technically will work, but is rarely practical. Often, a better solution is to use a speaker selector switch with impedance protection. These are connected adjacent to the amp, and all the speakers are then connected to the switch. Speaker selector switches use one of 3 methods to provide impedance protection, or impedance matching. One method is to combine the speakers in a series parallel combination internally. This saves you having to figure out the wiring. This method also gives full power to a pair of speakers if only one pair is selected. This method works best for 2 or 4 pairs of speakers only. It is not used for 6 or more pairs of speakers. Speaker selectors which use series parallel switching tend to look like this. They have no protection switch. The second method of impedance protection is to use a series resistor. A resistor, normally around 4 ohms, is put in series with the parallel speakers. Remember the total impedance of 4 ohm speakers in parallel? It was 1 ohm. 4 ohms in series with 1 ohm gives a total load impedance of 5 ohms, which makes the amp happy. If you have 4 8 ohm speakers in parallel, the speaker impedance is 2 ohms. 4 ohms in series with 2 ohms gives a total load impedance of 6 ohms, which is also good for the amp. Speaker selectors which use series resistors tend to look like this. Inside there are 2 high-power resistors and not much else. They normally have air vents for when the resistors get hot. They also have a protection switch or something similar. The switch is used when you have only one pair of speakers switched on. This bypasses the resistor and connects the speaker directly to the amp. The third method of impedance protection uses transformers. A transformer basically multiplies the speaker impedance. If the multiplier is set to times 4, then the impedance of each speaker is multiplied by 4. So with 4 8 ohm speakers, each speaker would appear to have an impedance of 32 ohms. The calculator tells us 4 lots of 32 ohms in parallel equals 8 ohms. All good. With 8 ohm speakers, you could set the multiplier to times 2. This would make each of the 8 ohm speakers look like 16 ohms. The calculator tells us 4 16 ohms in parallel equals 4 ohms. No problems. However, if you have 4 ohm speakers and select times 2, then each speaker looks like 8 ohms. And the calculator tells us 4 8 ohms in parallel gives a total impedance of only 2 ohms. Not good. However, if the multiplier is switched to times 4, then each speaker looks like 16 ohms. The calculator tells us 4 16 ohms in parallel give a total impedance of 4 ohms. This is fine for the amp. Speaker selectors which use transformers for impedance matching look like this. They mostly incorporate individual volume control for each zone. They normally don't need ventilation and don't have a protection switch. Inside there are individual transformers for the left and right channel of each zone. On the rear of some there is a multiplier switch which you set during installation. In summary, no matter how many speakers you have connected to one amp, whether they are wired in series or parallel, whether you use any type of speaker selector switch, the total load impedance must be above the minimum impedance the amp is designed for. Remember, we have looked at 1 amp only. In practice, the methods mentioned need to be duplicated for each amp. For more information, read the articles on connecting speakers on the website.